Hello everyone, and welcome to our fourth video on correlations, where we are going to be looking at the shape and form of correlations to see what that tells us about the behavior between the two variables that we're looking at and how we could expect to describe those variables and interpret the strength between those variables, right? So again, just a quick refresher. When we're looking at correlations, we are looking at the relationships or associations between two scores. When we're looking at this relationship or this association, there are three things that we can consider. The first is direction. What is the direction of the correlation? Is it positive or negative? The second is the form. Is it linear or nonlinear? And the third is degree and strength. This has to do with the size of the coefficient between +1 and -1, right? So we're going to look at this a little bit more closely in a second. What I do want to point out here is that anytime you see a correlation or a regression, which comes from correlation, it's a type of relationship test. Anytime you see the data for those, you'll see it presented as a scatter plot where one variable is on one side and another variable is on the other side. And we're plotting those together so that we can kind of see visually how these are related. So we can see that there is kind of a pattern here, and there's a pattern, a downward pattern here, an upward pattern here, another upward pattern here. We notice that these aren't clustered around the line as much as these are. So this isn't as strong of a pattern. And we see that these are kind of just spread out all over the place, that maybe there isn't much of a pattern between these here, in which case we would have no correlation. So let's look at a couple of those examples in a little bit more detail. So this is looking at degrees of correlation, so that's the strength, and then the type of correlation, so this is the form. What I want to focus on here are these two terms, direction and form. So direction here, where they're both going up, whereas this value goes up, this value goes up. They're both going in an upward direction. They're both moving in the same direction. This would be an example of a positive correlation, right? So anytime they're both going up in the same, they're both going in the same direction, whether it means that both of the values are going higher at the same time, or if it means that both of the values are going down at the same time, as long as both values are moving in the same direction, we have a positive correlation, okay? There's a positive relationship. They are both moving in the same direction, whether that is up or down. We get a negative relationship whenever we look at how one value goes up and the other value goes down, okay? So let's see, an example of a positive correlation would be traditionally, the more hours you spend in class, the more points you will get on your exam, for example, right? So as one goes up, the other one also goes up. There's a direct relationship between the two. We have a positive correlation, okay? Another one that would be considered a positive correlation would be as the number of calories you eat goes down, your weight on the scale also goes down. So those are still directly related. There's a direct relationship between the two. They're moving in the same direction. So even though both of them are going down, they are both being reduced in value, it's still a positive correlation. I know that sounds kind of counterintuitive for the terminology, but just remember that if they're going in the same direction, whether it's up or down, as long as they're both going in the same direction, it is a positive correlation. In this example here, as the number of calories that you eat increases, the amount of weight that you lose decreases. They are moving in opposite directions. So in that particular example, we would have a negative correlation. There is an inverse relationship between the two, right? So we have a negative correlation. So if they're going in the same direction, whether they're both going up or they're both going down, we have a positive correlation. If one value goes up and the other value is going down, we have a negative correlation. And I'm going to give you guys a self-check assignment that you'll find at the bottom of this module to where you can kind of test your understanding of that concept, because I promise you it will be on the exam, and it's one that students tend to struggle with. So we're going to get some practice in during this module before we jump into that exam. So that's direction. Direction is it positive or is it negative? Form has to do with this shape here, right? So this is linear, makes a line. So linear, line. This one is linear, it makes a line. This one is linear, makes a line. This one is linear, and it makes a line. Okay? This one, there's not really a relationship. As one goes up, the other one doesn't really change. Same for this one. As one goes up, the other one doesn't really change. Okay? A little bit, but for this one, there is no change whatsoever. In that particular sense, we would say that there is no relationship. It's just a cloud of dots, right? There is no correlation between those two variables, right? So maybe this is the hours you spend studying correlated with how many cheeseburgers you eat in a week. We find that there's no pattern between those things. People that study a lot eat the same amount of cheeseburgers as people who don't study at all. So there's no relationship between those variables, okay? So we have no relationship where it's just a cloud. We have positive relationships where they both are going up or they're both are going down. And then negative relationships where as one value goes down, the other value goes up. Okay? So that is direction. Form is the cloud here. There's no correlation here. That form could also be linear and it could be curved, right? For what we're talking about in this class and what you're going to do in most of your stats classes, you're going to be looking at something linear. And before you're wondering, I can't think of a curved correlation, there are lots of things that are curved correlations if you think about them for a long enough period of time and you measure them for a long enough period of time. So for example, if you talk about drinking water, down here, let's say it's people who aren't really drinking any water at all and their overall health is pretty low. The more water they add into their day, they tend to feel a little bit better, right? If you're more hydrated, you tend to feel a little bit better. Your overall health might have a slight uptick in quality. But if you start drinking way too much water, that starts to go down. The water starts to have a negative effect on your health. So up here, it had a positive relationship, and after you get to a certain amount of water where it starts to be too much, it starts to be a negative relationship. Same thing for exercise. If you don't exercise at all, your health is probably not that great compared to other people. If you don't move around at all, the more exercise you incorporate into your day, the more movement you incorporate, your health or your overall feeling of wellness may tend to go up. But then you get to that point where maybe you're exercising too much. You're just wearing your muscles down. You're doing too much. Your body can't handle it. Your health starts to go down. So all of these things have this shape where they increase to a certain time limit and then they start to decrease. That doesn't apply to every correlation. Those are just a couple of examples. But yeah, that would be an example of a curved correlation. So you don't need to know much about those for this course. What you do need to know is that they come in different shapes and that they are positive and negative, what that means, and that if there's no correlation, it means that one is increasing or decreasing and the other one isn't changing at all. And you'll be able to test your knowledge of no correlation, positive correlation, and negative correlation in one of the self-check activities in this module. So we talked about direction, we talked about form, both linear and nonlinear, we talked about positive or negative. The last thing I want us to talk about is degree and strength, and we're going to measure that on a scale of +1 to -1, right? So what does that look like? Here's an example of a weak correlation and a strong correlation. The closer items are to a straight line, the stronger that relationship is, okay? So this one here, this is a perfect correlation. It is a straight line. This is a weak correlation. We can see kind of the shape of a straight line. We can see a downward pattern, but the little dots are kind of loose. They're kind of all over the place, right? They're not as loose as no correlation, where we see that there's just kind of no pattern whatsoever. We see a slight pattern, but it's very weak, okay? So the closer it is to a straight line, the stronger it is. The further away it is from a straight line, the weaker it is. And if it gets away from a straight line completely, like this example, then we say that there is no correlation. So how do we define this or show this numerically? Obviously, this is visual, but we also get output in SPSS. That's our statistical program that you'll be introduced to in your statistics courses. It gives us a value, and that value is always going to be on a scale of -1 to +1, okay? So if you guys think back to absolute values whenever you were in middle school and high school, absolute value of -1 is the same as +1, right? It's 1. The negative just tells us which side of the line that it's on, right? If it's below 0, if it's above 0, if it's negative, or if it's positive. That -1 means that it's a negative correlation. So this would be a correlation of -1. +1 tells us that it's a positive correlation. So this is a +1, okay? No correlation has a value of 0. But we know there are tons of numbers between 0 and +1, and there are tons of numbers between 0 and -1, right? So maybe this is a -0.2 because it's kind of loose. Maybe this is a -0.7 because it's getting close to a line, but it's not all the way there. It's a -0.7. And this is a -1, the whole number 1. Same thing with these. Maybe we say that this is a +0.2. We say that this one is a +0.7 and this is a +1. Just because this one is a +7 and this one is a -7 doesn't mean that the positive one is stronger than the negative one here. That positive and negative just tells us the direction. The number itself, 0.7, tells us how strong it is. So if this is a +0.7 and this is a -0.7, they both have a strength of 0.7, which means that they are both equally strong. They're just going in different directions, okay? I'm not going to ask you about those values in this course, but that part, that number, we call it the correlation coefficient, is going to be very important when you get into your statistics courses. What I want you to know for this course is that the closer it is to just being a mess of dots, the weaker it is. If it is a complete mess, it's a 0. The closer it is to a straight line, the closer it is to a perfect correlation or a value of 1 or -1. That number itself tells us how strong it is between 0 and 1, and the negative part tells us which direction it's going in. So I encourage you to go down to the self-check, to look at the self-check items and see the self-check for directions, positive and negative correlation activity, where I will give you an example of a statement that describes the relationship between two variables, and you'll select whether you think it's positive, negative, or no correlation. If you do that self-check and you're still very confused about what the answers are, let me know and I'm happy to work through this with you. This is kind of a foundation of what you're going to do in statistics. So it's important that we nail that down best we can. If you have any questions, let me know. Otherwise, I will see you all in the next video.